Okay, this is the question that differentiates you as grade 11s. We are dealing with radical roots, which are still zeros. Okay, these are just zeros, but they're ugly, and we're given a point. So if we have zeros and a point, we have to use factored form. But it's going to get a little bit hairy, okay? So just bear with me through all this. So our factored form basic expression is a x minus s, x minus t. So we've been given information in this question. We've been given through a point, which is x at y, and we've been given two zeros. One of them that happens there, and one of them that happens there. So this whole thing is s, and this whole thing is t. Our steps don't really change, as far as how to solve for x, but some of our algebra gets a little bit ridiculous because these s and t values have two different pieces to them instead of some of the other questions when they just had one number. So let's go through and let's plug some stuff in. Now, we are going to work backwards. We're going to create an equation in standard form where a is 1. So what we mean while we're dealing with all of this chaos of the zeros, you kind of just don't worry about the a right now. We're going to bring that back in later when we actually solve for it, but things are about to get crazy with the zeros. So all we want to do in our first step is take the s and the t value and plug them into the equation because this is going to be tricky. So it's a negative s. Because s has more than one piece, we have to put it in brackets. 3 plus root 5. And then our other bracket is x minus t, and t is 3 minus root 5. It doesn't matter which one you made s and which one you made t. Okay, this is where we have to start becoming grade 11s. And we recognize that although this is ugly, it's basically a subtraction of a bracket. And when there's a subtraction, the negative 1 has to be distributed into both terms. Okay, so we get x minus 3 minus root 5, x minus 3 plus root 5. Okay, so that looks ridiculous. We've never seen anything like that before. That's okay, we're on the right track. Now what we want to do is we want to be able to force this equation into standard form if we can, because I don't know how to work with all of this plus or minus roots business. We're not going to get exact answers. So if this was a question that was a FOIL question, and you had this, x plus 1, x plus 2, you would go first, outside, inside, last. But what you're doing is you're guaranteeing that this piece of the first bracket gets multiplied by everything in the second bracket. And then this piece of the first bracket gets multiplied by everything in the second bracket. In this question, we've got 3 pieces in our first bracket. So we want this x to hit the x, to hit the negative 3, and to hit the root 5. Okay, then we want the negative 3 to hit the x, to hit the 3. This is like FOIL on roids, to hit the root 5. And then we want the negative root 5 to hit the x, to hit the 3, to hit the 5. So just by looking at that, when we do our super jacked up FOIL, we're going to have 9 pieces in our answer. Usually we had 4 pieces. This one we're going to have 9 pieces. Okay, let's do it. There's a reason we're doing it. I'm not leading you astray. Watch what's going to happen. But we got to get there first. Okay, x times x squared. X times negative 3, negative 3x. X times positive root 5, positive x root 5. That's the coefficient in front multiplying by the root 5. Okay, here. Negative 3 times x, negative 3x. Negative 3 times negative 3, positive 9. I'm just going to move this because I feel it's important. Up a little bit. Okay, where was I? Positive 9. That was the negative 3 times negative 3, so I've got to go negative 3 times root 5, negative 3 root 5. Okay, negative root 5 times x, negative x root 5. Negative root 5 times negative 3, that's a positive 3 root 5. And negative root 5 times positive root 5 is negative root 25. Holy smokes. Watch what happens. X squared, there's no other x squareds there. Negative 3x. Ooh, there's a negative 3x. That's good. Those have to go together. X root 5. There's an x root 5. Okay, those have to go together. 3 root 5, positive 3 root 5. Those have to go together. And the last thing that has to go together would be this 9. And when we solve that, that's actually going to give us a normal number. So let's look. This is colorful and chaos. X squared. Negative root 3. I'm making negative 3x minus 3x. Negative 6x. Positive x root 5, negative x root 5. Bingo bango. Bang, bang. Love it. Oh, I already dealt with that one. Let's go to the green. Negative 3 root 5, positive 3, bang, bang. Yes. Then we've got, this is 9. This gives us a minus 5. 9 minus 5 is 4. Look at all of that chaos. Look at what it ended up giving us. Isn't that beautiful? Okay, so we've created a situation where we assumed our A value was 1. Okay, because we just went through and did all the work. Now we're saying our A value isn't 1. We're going to find what our A value is. Okay. So we did all of this work, and we want to be able to use the point that we know, which is 2 at negative 12. We want to be able to plug that in to solve for what this A value actually is. So we're going to say y equals ax squared minus 6x plus 4. The reason the A value is only affiliated with the x squared, it doesn't, like, there's no A here. This is A, B, and C. So this is the only place that there's an A value. And in standard form, it's good because it's isolated out front. So let's put in an x of 2 and a y of negative 12 and see what happens. Negative 12. Let's put in an x of 2, minus 6, put a 2 there, plus 4. We get negative 12 equals A multiplied by 4 minus 12 plus 4. Be careful of your bed mass here. We are allowed to put those together because they're addition and subtraction, but we can't do anything over here because that's multiplication. So be very careful. Negative 12 equals A 4. That is negative 8. And now it's just like our vertex form question where we have to get rid of that negative 8 first. Positive 8, positive 8. Let's add 8 to negative 12. That's negative 4. And then we've got A multiplied by 4. We have to divide there and there. Good. And then we get negative 1 equals A. So here we go. all of that stuff there, our final equation is y equals negative x squared minus 6x plus 4. Good job. I have a try for you on this question, and I want you to try it on your own, and I'll post the solution here, but I believe this one's actually on your handout.